All right, we will continue to hear from users and user requirements with Mike Bany. Take it away. That's the one.
Thanks, Brad. So, I'm Mike Bany for Fox. One of the roles I have is related to broadcast technology and InfoSec. And I thought I'd go through a few of the issues that we've been working through. So recently we've had to look at a lot of things with 2110 media with untrusted sources. For example, third-party providers or carriers like it could be like a Lumen or a Verizon that is now starting to offer 2110 drop-off of feeds or reception of feeds. Third-party managed equipment like maybe a LiveView device, something like that, that has 2110 interfaces. Even for us, it's other business units. We don't necessarily allow everything to go everywhere within a company because then you could really have trouble if one thing got compromised. And then DMZ equipment, for example, like a wrist encoder with 2110. So some potential risks we have that we've been looking at would be the 2110 streams themselves, their IP, although it's less concerning because we haven't seen a lot of attacks with that type of thing. Even in MPEG, we haven't really seen a lot of attacks using M. I'm not saying people can't figure out how to do it, but we haven't seen that. A big one that we've really been looking at is the NMOS APIs. For us, anyway, broadcast level security does not allow incoming connections from lower security networks. And NMOS itself, the way it's set up, we have bidirectional communication between devices. And that then goes to your central control system. So for us, in the days of SDI, you had your central control system for your router that all your control panels connected to, but that was it. You could have that on an isolated network, nothing else touched it. Now, when you build a 2110 plant, you have your central control system that touches every single device on your network. And now you have things in lower security areas talking to that also. So a couple of potential solutions we've looked at, and I'll go through each one here in detail, but basically using SDI for security. It's funny, but it works. And it's funny, our InfoSec people have said, you know, when we talk about control and stuff, a serial port is what they would prefer, you know, and so this is serial also. Only stream the 2110 signals, or how do we secure NMOS? So obviously converting to SDI use of the gateway, instead of the first diagram we have, you have all your devices sending SDI into your gateway, everything's secure, like I said. And I'll be honest, when we look at all the other options, if you're looking at complexity and simplicity of support, it's funny, but this is probably the easiest one to do right now. Only stream the 2110 signals. So that would require maybe a static configuration, no NMOS control or registration, out of band SDP, possibly via a file transfer, maybe. But again, that's not very real time if you change your sources or anything that. Another thing we've looked at is using a restreamer gateway. But even then, that still has a device that's spanning 2 security zones. So we have to look at that device and see, can it be compromised, or are the cards separate where the backplane isn't transiting IP and there's no control of traffic? It doesn't also necessarily allow automatic media changes if you change the frame rate or the resolution, like that. And then the last one is securing NMOS. And I've looked through the NMOS security recommendations, and I think a lot of them are good, you know, OAuth, those types of things. But I know for us, for example, with VMware, we generally get patch requests every week where, oh, we need to lock everything down until we get this patch because it's a 0-day vulnerability. Those things all have passwords too, and OAuth and that type of thing, but there's still ways to compromise them. And I'm guessing that we haven't spent a huge amount of time verifying how easy it would be to compromise the NMOS APIs, that type of thing. Then the last one we've looked at a little bit, which I don't think actually exists, but some sort of NMOS proxy. I know we've talked about it in some of the standards things, but I don't know that there's any open source code or anything like that, but a way to satisfy our InfoSec requirements while doing secure. So for example, if we had some sort of NMOS proxy device in the DMZ area that all these devices could talk to, but then there was a one-way connection from your internal stuff to that proxy. And I'm not, like I said, I haven't spent enough time on it to see how that could work, but that certainly makes our InfoSec people very happy to see arrows only going one direction.
We'll go that later.
There we go. Conclusion, and like I said, this was a short presentation. I was asked to kind of just go over this, but Andy asked me for all the rest of my time. So
Between you, I was ready to stand up for you. But, you worked something out yourself.
There we go. So what we've seen, security requirements are changing continuously. The threat actors are getting better and better, and we're always looking at doing different things, whether it's NDR implementations, EDR, that type of thing. It's one of the reasons the topics at VidTrans next are, because this is the thing we spend most of our time on any project. We'll get in a room with a vendor and we tell them, here's what our best practices are. And you can just see they can't do it, and so this is something we really need to start talking about a lot more. And I say there's a lot of work to be done.
Right. Thank you, Mike.